Welcome back, everyone. Today we're going to continue on with 2 decimal 2, and we're going to look at special triangles. Special triangles come from your right angle triangles. These angles have exact values that are commonly used when you're working with exact values and your primary trig ratios. So we're going to look at, it's from 0 to 90, it's basically a reference angles. We're going to look at 30, 45, and 60, and we can determine exact values of these trig ratios. So the 2 triangles that we're going to use in this particular case are the 30, 60, 90 right angle triangle and the 45, 45, 90 right angle triangle. Alright, so we're going to do a little investigation to see what happens here. We're going to use our formulas for the primary trig ratios that we came up with in the previous section. You'll see them in the chart below in a minute. Alright, so remember, when we talk about exact values, this is no decimals. Alright, these are integers, fractions, radicals. These are all examples of exact values. So we're going to have some rational numbers here. So basically, we're going to have a numerator and denominator, right? Where the denominator will be your whole number, and the numerator can be again, it can be irrational. It's helped to express these as exact values, right? So we look at the chart here in our triangles. So we have the sine theta is equal to, if you do recall, it's y over r. So I've picked the angle, remember, as your y, x, and r. R is your hypotenuse, if you do recall. X will run on the horizontal and y will run vertically. As you can see here, that's where I got the x and y value. So the angle 30, we're going to use the first special triangle, and I put the sides on here. I guess I should indicate that. So the side opposite of 30 is the smallest side, which would be 1. Then they make the hypotenuse 2, and when you solve for that using the Pythagorean theorem, you get root 3. Okay? These will be given to you. I'll show you that a little later on. It's good to commit them to memory, though. You may not always have the opportunity to get them. So they're pretty easy too. And then obviously the 45, both sides are the same, opposite 45, so 1, 1, and then we calculated the square root of 2 because 1 squared is 1, 1 squared is 1, 1 plus 1 is 2. Take the square root of both sides and you get the square root of 2. Okay, so these values in the chart are coming from these 2 special triangles that you see at the bottom. Alright, so 30, so the sine of 30 degrees, this is how the chart works. The sine of 30 degrees is y over r, so it's 1 over r, the hypotenuse is 2, right? So 1/2. And you can check that on your calculator if you wish. I'll bring that up now. So just to check that, make sure again it's in degrees here, as you can see up top. To change that on this calculator is mode, as you recall. So the sine of 30, and we said it's going to be 1/2, and it is decimal 5. And your calculator is going to give you the decimal. Some of you have a calculator, if you do recall it, will actually give you the. I'll show you when we get to one. It'll give you that exact value, which is nice. Okay, and then we do the sine of 45. Comes from over here. Remember, sine is, so we take 45 opposite over hypotenuse, so 1 over root 2. And if we rationalize it, we multiply both sides by the square root of 2. Or sorry, the numerator and denominator, my apologies, by the square root of 2, and we get square root 2 over 2. Or you can leave it as 1 root 2 sometimes. Either one of these values are fine. If it needs to be rationalized, use the second value. So the sine of 45 will be, obviously it doesn't give you back the square root of 2 over 2, but I'll show you that that's the same. Square root of 2 divided by 2 to give you back the same value, and 1 divided by the square root of 2. Again, this is a nice way to check to make sure you rationalize your denominator correctly as well. You'll notice that they're all equivalent. They're all equal to decimal 7071. So nice way to check as well. And then the last one is the sine of 60 for sine, and obviously sine is the opposite, so opposite over hypotenuse. Now the x is, it's coming up as x this time because the orientation has to change, right? So the 60 would be down here and 30 would be up here, so that's why I'm using x this time. So in the first one, just be mindful of that. So if I don't want to confuse you, right? But 60 over that. So in this case, it will be x over y, x over r. But again, that's just because of the orientation. The 60 is up here. If I were to take that in orientation to change it, put the 60 down in the bottom here and the 30 up top, then obviously the sides opposite would change, right? The root 3 would be here and the 1 would be here. So just be careful of that. As you can see in the cos, it's the opposite actually. Okay, and the rest of the chart I've just filled in doing the same thing. Using these special triangles, this chart doesn't change. Sine of 30 is always 1/2. The sine of 45 is 1 over root 2, or 2 over, root 2 over 2. And the sine of 60 is always root 3 over 2. You can check that again on your calculator. Sine 60, you get decimal 8660. And we said that's going to be equal to the square root of 3 divided by 2. Now remember, you have to put the plus over because it's the root 3. It's not the square root of 3 over 2, it's just the square root of 3 divided by 2. Then you get decimal 8660. See the 30, right? So these are used a lot when we use our special triangles, when we're looking for exact values. You'll refer back to these. Okay. If you go back to the very first page, you'll notice that these values are right here actually. You'll notice that the point values are there because it's all connected. So remember we said the sine of 30 was equal to y over r. Well, it's equal to y, which is 1/2, and cos of 30 is equal to root 3 over 2, as you can see from the chart on that page. So it's they're all connected that way. It's pretty neat. I want you to play with these for a little while, and you see them, it'll start to make a little more sense. But right now, you can use this chart as a summary on page 12 when you're trying to find those values, right? Sine 30, boom. Okay? So this brings us to our next exercise. Those special triangles can only be used for the 0 to 90 degrees. However, they can also be used for anything past 90 degrees. We just got to bring it back to our reference angle. So sine of 135, you go back to your summary sheet on page 11. I'll scroll up here. There's your summary. So we know that the sine of 45 and sine of 135, they both have a reference angle of 45 degrees. And I'll show you what I mean by that. I'm going to bring that up right now. So it's mathopenref.com. I'll make sure I pop that in there. So look at this. It's right here. It's actually neat that it was on 35. So, or sorry, 135. There we go. See how the reference angle is 45? And in quadrant 1 is 45. So you'll notice when you flick back to your sheet, the sine is also positive here. So the sine of 45 and the sine of 135, they're actually equivalent. They're equal to the same thing. So when you're asked to express the sine of 135 as an exact value, it's equivalent to the sine of 45 because of that cast rule. Remember, the second quadrant, all your sine is positive. All right? So to make sense of that, if I asked you for the sine of 225, let's go back to our, so if I asked you the sine of 225, you'll notice your reference angle again is 45. So the sine of 45 and the sine of 225 are very close. They're not exactly the same. They're close because the only difference is they're negative. So if you look up here, sine is negative in quadrant 3. So the sine of 225 is equal to the negative sine of 45. I'll show you what I mean by that. So let's take a look. Oh, we briefly did this in Math 11, and we didn't really say why, but this is why. There's the sine of 45. There's a sine of 135. Also the same. So you're probably going to guess it. What if I put 225 in? So the reference angle of 45, yes, it's the same value, but it's negative because quadrant 3 and 4, it's negative. So what's the other angle that would come with this? You'd be right if you guessed 315 degrees, because that would also give you a reference angle of 45. There it is. 315 and 45 are related, right? The reference angle and 315 are equivalent. The only difference is one is negative based on the cash rule. Sine is negative in quadrant 4. So let's go back to our calculator. Prove that again. So if you guessed that the sine of 315 is negative decimal 7071, you'd be correct. And remember, decimal 7071 is the square root of 2 divided by 2. So negative square root of 2 divided by 2. That's also equal to negative there. And again, that all relates to your front page, which is, I do actually give you on an exam, not that we're going to have one this year, and we're going to explore this again next year as well, but it's pretty neat. It's all related to this unit circle, which is pretty cool. Alright, so you can see that the 45, 135, 215, and 315, they're all related. And you notice their points are all the same, root 2 over 2, but one's obviously negative and one's positive, and that's due to the fact of the unit circle of what quadrant they fall in. Positive, positive. Sine is positive, cos is negative. Sine is negative, cos is negative. That's why tan is positive. And right here, we have our cos is positive, because it's your x value, and y is negative. So it's all related. And again, once you work with that for a little while, you'll get more of an understanding of that. All right. Let's continue on. So the tan of 135, we know is going to be the opposite sine of tan of 45, because 135 is in your quadrant 2, which is negative. Tan of 45 is, remember, we always bring it back to our reference angle. It's going to be minus tan of 45 because it's opposite. And again, you can always check this on your calculator, which is nice. So tan of 135, you're getting back negative 1. And the tan of 45, as we know, is going to be positive 1. So that means that these are opposite signs, right? Tan of 135 and tan of 45 is the reference angle there, which is pretty cool. And then the tan of negative 60 is equal to cos of 60. Negative, if you do recall, remember negative goes in clockwise, right? So we got cos of negative 60 is equal to cos of positive 60, and that is due to the fact that quadrant 1, cos of 60 is positive, and quadrant 4, the cos of negative 60 is also positive. So that is why these are equal. 1/2. And again, you can check these, which is beautiful. Cos of 60, 1/2, cos of negative 60 also gives you 1/2. That's because 60 is in quadrant 1, so it's positive. Cos of negative 60 is the opposite direction, which is quadrant 4. Therefore, it's also positive because of your rule of your cast. Remember. So we'll go back to this as the video comes to an end. Because remember, we're relating back to this quick summary here. All are positive in quadrant 1. That's 0 to 90. Sine is the only one that's positive in quadrant 2. The rest, cos and tan, are negative. Quadrant 3, sine and cos are both negative. Tan is positive. All right, and the last quadrant, quadrant 4, cos is positive, sine and tan are negative. So we'll pick it up in the next video on page 13. We'll finish that off, and then we'll continue on